Okay, so today we're going to be learning about solving absolute value equations. And the first thing you need to understand about these are what is an absolute value. So the official definition of absolute value is the distance from zero. And since distance is always positive, that is why the absolute value of any number is going to be positive. So if we just have this simple equation right here, the absolute value of x equals 7, there are two different values of x that you can put in here to make this equation true. Okay, we know the absolute value of a positive will always be a positive, and we know the absolute value of a negative will become positive. So the two values of x that we could put in here for this equation would be 7 and negative 7. Okay, so for our first real example, we have the absolute value of 3 plus 8x equals 27. So just like that previous section with the 7s, there's going to be two answers. So we want to set up two cases. Okay, first case is pretty much just this equation without the absolute value symbols. So we're going to be solving 3 plus 8x equals 27. And case 2, we're going to leave the left-hand side the same. The left-hand side doesn't change, but our equation is now going to equal negative 27 instead of positive 27. Okay, so once you have both of these set up, you're going to solve both of them. Okay, you can do them one at a time, you can do them at the same time, but you're going to get two answers. So if we start with case 1, we're going to subtract 3 from both sides. So subtracting 3 from both sides, we are going to get 8x equals 24. Okay, and to solve for x, we would need to divide both sides by 8. And we get x equals 3. Okay, and you can check your answers by plugging them in and making sure it's something that's true. So if we plug in 3 here, 8 times 3 is 24, 24 plus 3 is 27, and the absolute value of 27 is still 27. So if you ever want to check your answers, that's how you do that. Okay, so we know that one's correct. And then we move on to case 2. So the first step is still the same. We're subtracting 3 from both sides. But in this problem, when we subtract 3, since both of those numbers there are negative, this is going to remain negative, and we're going to add the numbers. So 27 plus 3 is 30. Okay, so this equals 8x. Okay, and this time, when we divide by 8, 8 is not going to divide evenly into negative 30. Okay, it's still okay to have a fraction, but what we would want to do is reduce the fraction. So the only number that can divide evenly into both of these numbers is 2. So if we reduce by 2, we're going to get a negative 15 over 4. Okay, and again, you can check your answer. Okay, it's not going to look as pretty as this one, but if we plug in negative 15 over 4, okay, you'd want to take the 8 and divide it by 4 first to get 2. 2 times negative 15 is negative 30. Okay, negative 30 plus this 3 would make a negative 27 inside the absolute value. And again, absolute value of a negative will equal a positive, which would be positive 27. So that's a way to check that answer as well. Alright, so for our next example, we have negative 2 times the absolute value of 4x plus 1 minus 3 equals negative 9. So, unlike the previous problem, there's some extra stuff going on over here on the left-hand side. It's not just the absolute value of something. There's something being multiplied to it and something being subtracted. So, whenever you have a problem that looks like this, the key is to get the absolute value alone before setting up the two cases. So that means we need to do something with the negative 2 and the minus 3 before we do case 1 and case 2. So the first thing we want to do is to get rid of this negative 3. So in order to get rid of that 3, we're going to want to add it to both sides of the equation. Okay, so when we add, we're going to get a negative 6 here. Okay, we're still going to have the absolute value. So we have negative 2 times the absolute value of 4x plus 1. Okay, and that equals negative 6. But we still have this negative 2 here that we don't want. So there are two choices for you. You could distribute the negative 2, which will make the numbers bigger, or you could actually divide negative 2 on both sides, which is what I'm going to do. So we divide both sides by negative 2. Okay, it's okay for us to do this. Okay, it's just like having, 2x equals 6. You would divide by that 2. So it's the same idea. These 2's would cancel. Okay, we still have the absolute value. Okay, we have the absolute value of 4x plus 1 equals a positive 3, because when you divide two negatives, it equals a positive. Okay. So now that the absolute value is on the left and it's completely by itself, nothing on the outside being multiplied or added or subtracted, now that it looks like this, we can set up our two cases. Alright, so now that we have it simplified, what we want to do is set the two cases. So case 1, just like before, we're going to have the equation without the absolute value symbols. So we have 4x plus 1 equals 3. Okay, again, we're never going to change the left-hand side. Those signs will always stay the same. Okay, the only thing that changes is for case 2, the right-hand side, so only the 3 will change. So again, 4x plus 1 must stay the same. Okay, do not change the signs of the absolute value. Okay, so this case must equal negative 3. Okay, so if we go ahead and start with case 1, first thing we want to do again is to subtract 1 from both sides. Okay, and we're going to get 4x equals 2. Okay, and when you divide by 4, okay, make sure you don't divide by 2. You always want to divide by the number in front of x. Okay, dividing by 4, the bigger number is going to be on the bottom. So don't put 2 for your answer. That's a common mistake. Okay, since the bigger number is on the bottom, it stays as a fraction, and you just want to reduce. So 2/4 is the same as 1/2. Okay, you can reduce by 2. Okay, so our first answer is 1/2. And you can plug that in and check it if you want to. Okay, if we move on to case 2, again, we're going to start off by subtracting 1 from both sides. But since that is a negative 3, we're going to get negative 4 when we add them. Okay, so we're getting 4x equals negative 4. Okay, and just like the last problem, we want to divide by this 4. Okay, so a negative divided by a positive will give us a negative. So our answer is going to be negative 1. Okay, and again, if you want to, you can plug it in. Make sure if you plug it in, you do the inside of the absolute value first. Treat it kind of like parentheses. Whatever you get in here, multiply by the negative 2, subtract 3, and you should get negative 9. Alright, here's our last problem. And if you notice this problem, the absolute value is not by itself. So hopefully you can guess that the first thing you're going to want to do is divide both sides by negative 5. So let's do this. Okay, divide the left and the right hand side by negative 5. Okay, so in doing this, we are going to get the absolute value of 3x minus 4 equals a negative 5. Okay, and this is where we want to actually really look at the problem. We said before that the absolute value of something is always going to equal a positive number. This is the first example where the absolute value equals a negative. Okay, that can never happen because it doesn't matter what you put in here for x. After you do the math in here, you're going to take the absolute value. Okay, when you take the absolute value, it's going to make any number that's in here positive. This can never equal a negative. So, after you have simplified any problem and the absolute value is by itself and it equals a negative number, don't go further. Your answer is going to be no solution. Okay, so again, if you get the absolute value of something equals a negative number, that is impossible. Okay, again, whatever you plug in here, after you multiply and subtract, you will have to take the absolute value, and the absolute value makes everything positive. So there's no way to get the negative 5. Therefore, there is no solution.